Good morning students. There is another video on calculations, mechanics. In the mechanics, motion concepts, if you take velocity, acceleration, graphs and relative motion, forces, etc. See, in the velocity, acceleration, constant acceleration, the last video we discussed x is equal to vt, average velocity in more detail we discussed. Some questions related to, see, forms of motion of equations if you take. See, the first question, the first point, displacement is equal to average velocity into time. So initial velocity plus final velocity upon 2. See, final velocity v equal to v naught, v is equal to u plus at. Similar to that, v is equal to v naught plus at. If you derive this, so the displacement is equal to average velocity into time. The displacement is equal to average velocity into time. So displacement is here. See, displacement is equal to average velocity, v equal to v naught. See, if you take it as v naught, see, v naught plus v by 2 into t, average velocity into t. So v equal to what? Again, v equal to can be written as, see, v naught plus at you can write, v naught plus at upon 2 into t you can write. So v naught plus v naught, 2 v naught will come, plus at upon 2 into t you can write. You can derive like this. So that becomes, if you split into two cases, 2 v naught, so t also if you multiply divided by 2 plus at into t, at square will come. So 2 get cancelled. It means that displacement v naught t plus of at square. You can derive in this way. You can derive in this method. So finally you got this equation, x equal to v naught t into plus v naught t plus of at square, v naught t plus of at square. So you can derive like this. So this is one derivation in the kinematics. See, coming to the next one, there is another equation, the forms of motion of equations. See, v square minus u square is equal to 2as. That form equation, if you derive it here, that you take here, just observe carefully here, v is equal to v naught plus at is given. So v minus v naught equal to what? V minus v naught equal to at will come. So then the displacement is equal to what you can write. Actually there is a formula, average velocity into time. Average velocity is nothing but v plus v naught by 2 into t. So from this you can write v plus v naught equal to 2x by t you can write. Let us hope this is the first equation and this is second equation. Multiply first equation with second equation. LHS of first should be multiplied with LHS of second. V minus v naught into v plus v naught is equal to at into 2x by t. So tt get cancelled. So a plus b into a minus b, that is a square minus b square. So v square minus v naught square is equal to 2ax. See, you can derive in this manner. See, the same thing you got here. V is equal to this one. V is equal to v naught square is equal to v square is equal to v naught square plus 2ax. The same thing we got here. So in this manner you can calculate easily. The derivations are also. See, there are some examples like distance, displacement if you try to calculate. So the distance is, initial velocity will take here. The initial velocity is, let us take initial velocity is, see, 10 meters per second, and final velocity, the final velocity is, see, 20 meters per second. The final velocity is 20 meters per second. Then what will be the distance travelled? See, initial velocity is 10, final velocity is 20. So the average velocity is 15. But the distance if you give, the distance value, it is travelled, let us say, see 10 meters, if it is travelled 10 meters. See, if it is travelled, distance is 10 meters, then acceleration will be 15 meters per second square. See how you got this value, just observe here. See the value here, what it is given, we are given as initial velocity is given. Initial velocity is what? That is 10 meters per second. And final velocity is what? 20 meters per second. And displacement is how much it is given? That is 10 meters is given. So now acceleration, if you want to find out, acceleration is equal to v square minus v naught square upon 2x. V square minus v naught square upon 2x. If you calculate v square, 20 square will come. So 10 square upon 2 into 10 will come. So 20 plus 10, 30, 20 minus 10. So that is a plus b into a minus b. So 10 upon 20 will come. 2 into 10. 10 get cancelled. It is 15. See, that's why. See, average velocity is 15 meters per second. Acceleration is 15. The time also you got answer. Time is also, you got all answers you got very quickly within a short time. See, just within a fraction of second you got these answers. For example, if you take, instead of 10 you got, you give 100. Here you give 200. See, if you give 200 here, the displacement if you give 100, the displacement is another 100. So now the calculations, 150 meters per second square acceleration, or you can give any value. Instead of this, some random values also you can give. See the random values like, see you give 150 or 20 you give here. Here something you give, see 300 or 230 you give. Here displacement you give. The displacement value you just change, so different value like 90 meters you take. Then what is the answer of distance? Here 90, 230, 20 you got. 125 is the average velocity. Acceleration is 291.6. Time taken is 0.72 seconds. How fast you can do the calculation? Just imagine. So by changing the values, you will, the same formula is only one, that is v square minus u square is equal to, so 2ax, or v square minus v naught square is equal to 2ax. So, or similarly time is v is equal to u plus at, v is equal to v naught plus at. The formulas are only that, but calculations can be done very fast method. If you practice like this by changing numbers, see, instead of doing the work, you can do calculations within a fraction of time. So that is one important, but you have to learn more problems. If you practice more, so knowledge you are going to gain. That you should understand here. There is a different initial velocity, final velocity, so different methods. So linear motion, we already done this in the last video. So like this, calculations can be done within a short time. Many calculations can be done in the mechanics. Not only in mechanics, in all chapters. Thanks for watching this video. We'll continue in the next video.